Hello, everyone. Welcome to the second day of the Blockchain Community Day. My name is Palina, and today I'm excited to introduce you Dmitry Kovalevskiy with an engaging talk titled Building a Crypto Perpetuals Derivative Exchange. And here's Dmitry. Dmitry, hi, welcome to our conference, and thank you so much for being with us today. Could you please briefly introduce yourself to our audience?
Hi, and thank you for having me. So my name is Dmitry Kovalevskiy, and I'm building Hanji, which is an on-chain order book DEX. And before that, I worked as a quant in several banks and also as a product manager in fintech companies.
Okay.
And today I'd like to tell you about Hanji.
Okay, thank you so much. Just a small kind of reminder to everyone, feel free to drop your questions into our chat and we'll have a Q&A session at the end of the speech. So probably without further ado, let's dive right in. Dmitry, the floor is yours.
Yeah, thank you. So I'd like to introduce you to Hanji, which is an advanced central limit order book exchange, which is on-chain, decentralized, composable, and efficient. So first, we'll dive into the current trading venues that are accessible to users. So first, there are centralized central limit order book exchanges. So they use a central limit order book model, which is very efficient. They have low latency, and you don't need to spend gas to trade there. But they also have quite a lot of disadvantages. So first, they're non-composable, so you can't really build DeFi protocols on top of them. It's also quite complex to provide liquidity there, as it's an order book and you normally need to find a market maker to trade there. The listings are usually permissions, so you need to get an approval to launch a coin. And finally, they're custodial, so it means that they have credit risks. The most famous case would be the FTX, but also there were quite a lot of safety breaches with centralized exchanges in the past. Then there are decentralized exchanges such as AMMs or custom formula market makers. So they were pioneered by Uniswap. Now we have quite a lot of them. So they are fully decentralized, non-custodial. They are quite easy to provide liquidity to. They're composable, and you can launch a coin without getting approvals. But they also suffer from their own disadvantages, such as poor capital efficiency, permanent loss, NAV losses, and gas fees can also be quite expensive. And then finally, right now, off-chain and side-chain central limit order book exchanges starting to launch, such as the YDX, Hyperliquid, Vertex. So these exchanges have quite low latency, so not as low as centralized exchanges, but still quite low. They are non-custodial, and they also use the central limit order model, which is quite flexible. But they're still non-composable, so we can't really build other DeFi primitives around it. Bridging is required to access them, and most of them rely on some sort of centralized sequencer, which can lead to censorship and can also cause regulatory complications. So first and foremost, we'll focus on why do we believe that we need to have an central limit order book on-chain, and why can't we settle on AMM like Uniswap or virtual AMM like JMX. So yeah. First and foremost, the AMMs have much less capital efficiency. So for example, if we compare the Ethereum USD pair on AMM with the order book, we would see that AMMs have much worse capital efficiency and have higher spreads and higher slippage. So on the picture, we've translated AMM liquidity into an order book form, and we see that the spread is much wider. It is also well known that most AMM liquidity providers lose money, while Typically, market makers on central limit order book exchanges, they earn money on average. And yeah, so basically, central limit order books have much more liquidity and they are more sustainable. So that's why it makes sense to build them fully on chain. But why, if they are better, why central limit order books are not really used yet? So there are two problems. Second problem is easier. Basically, you need to pay gas fees each time you place an order. So for a long time, gas was very expensive on EVM networks. And because of that, the fully on-chain order book was not possible to launch. But the first problem is actually more important. The problem is that the most widely used and well-known matching algorithms are suboptimal and not really suitable to execute inside a smart contract. Because most of the matching algorithms have linear complexity in number of orders. So to illustrate this, imagine we have an order book, then we have price levels, and on each level we have some number of orders. And then imagine a big sell order comes, then typically most matched algorithms will iterate over all orders on the first level, then on the second level, and so on. And that would, that would basically be linear complexity in number of orders. And that would cause basically infinite gas costs. And so on chain, we have a gas limit on each contract call. And basically, with linear complexity, the algorithm is not guaranteed to execute fully within a single contract call. So that's why we need something better than that. And in Hanji, we use an algorithm pioneered by Jay Poon, which actually has logarithmic matching complexity. So the way it works is that it stores bid orders and ask orders in two prefix trees. To illustrate it, we will show the tree for bid orders. So here we have the key, which is a combination of price and order number. So each leaf of the tree is an order. So there are 4 orders in this particular tree. And each node basically stores some aggregated information of its children. So the key of the node is the common prefix of its children. So here it's 8 and 12 / 9 and 1 x. So x is different in 2 child orders, and this is the common prefix. And the nodes also store some quantity, which is the sum of quantities of each children orders, and some values, which is basically the dollar value of each of the children orders. And so by construction, we can see that this tree has a max height of 64, because key would have just 64 bits. So at most, there would be 64 levels. And then how can we actually execute an order with this tree? So imagine we have a sell 7 ETH at 1800 sell order. So the way we would execute it is we would go along the rightmost branch of the tree, and we will find the subtree that can be executed fully. So then we would give the seller the amount stored in this node, in the most apparent node of the subtree. Dollar amount we would give to the seller, And so the sell order is executed atomically in a single transaction. And then for the limit orders, to execute them, we would just remove them from the tree. And then as long as limit orders are not in the tree, they are treated as executed. And then the users can asynchronously claim the proceeds of their respective buys here. So as you have noticed, we just, in order to execute this order, we just went across the tree, which is not more than twice the tree height. So it should be less than 128 steps. And so we are guaranteed to fully execute each sell order within a single contract call. And we can do that while keeping the tick size very small, so we can have actually a lot of granularity for price, and we can handle billions of orders here. So, and then returning to the gas fee problem. So originally on Ethereum 01, gas fees are quite expensive, so the swap costs about $8. So then on Ethereum 02, such as Base Optimism, Ethereum gas fees are lower, but on average they're around 1 or 2 cents currently. And then you EVM networks launch, such as Etherlink, on Tezos, and some others, which would offer gas fees in order of magnitude lower. So we can see gas fees like 0.1 cent, which is really good for the order book model. And then regarding our matching algorithm, previously I've shown theoretically why does it work and why does it have actual algorithmic complexity, but also on the simulated data, it can be shown that more than 1 billion orders can be matched in a single transaction with less than 700K gas. And we also did quite a lot of gas optimizations. And you can say that both market orders and limit orders are more than 2 times cheaper than Uniswap. So thinking Uniswap, the kind of median swap fee is about 120, 140K gas, and we achieved 60K gas for a market order. And adding liquidity costs more than 300K gas on Uniswap, and limit order is just about 120K gas Hanji. And that would cost about 0.1% on Etherlink, the similar chains. So yeah, and bit of our roadmap. So we've started working on this project last year. So we launched internal testnet in March, and we will be launching the main beta in June, and perpetuals would come in July. So we would be probably the first fully on-chain perpetual DEX, fully on-chain DEX, which works on a general purpose EVM chain, not private chain. And regarding our product offering, so we would have deep liquidity on chain for main trading pairs such as BTC USD and ETH USD. We would have a fully composable perpetual exchange, which would allow other teams to launch structured products on top of our perps. So if you're familiar with the Ethereum protocol, which is basically a staked ETH and the short futures position. So things like that would be possible to launch in a single smart contract. And you would not need to utilize some custody provider and centralized exchange. We're also working on automated market making solutions that would allow users to launch LP tokens for an order book DEX. And those LP tokens would be also possible to use as a collateral in protocols like Aave. And finally, our goal is to bring the whole cycle of coin development on one platform. So basically, we will be launching coin launchpad, and our goal would be to take the coin from launch, from bootstrap period, all the way to the liquid perp markets. So I think that's pretty exciting. That's what we are working on. So yeah, that was my talk for today.
Great, Dmitry, thank you. That's so interesting. Our audience, please, I remind you to leave your questions in our chat while waiting for any questions. Actually, I have the questions that I'm always curious about, like the general expression. So could you please share your thoughts on the future trends in crypto derivatives market, especially in the terms of leveraging and risk management? What do you think about it?
Yeah, so I think we have, I think the general trend is to bring as much on-chain as possible. So for now, like last year, we have a lot of hybrid protocols which have like off-chain matching and on-chain risk management, like Vertex and YDX. And so I think this year and the next year, we would actually go on-chain like fully. So that's what we are building, but also more notable protocols like Hyperliquid. So Hyperliquid is the fastest growing perpetual exchange right now. So they've started purely as a perpetual exchange with their own private chain. But just recently, they've also launched spot markets, their chain. And they've also announced that they would transition from being a private chain to being a public, fully compatible EVM blockchain. So going to on-chain is one trend. The second trend is basically pushing limits on acceptable collateral. So there is a lot of critique on FTX, but the cool thing about it is that they actually allowed to use various assets as a collateral on their platform. And I think we will see lots of changes that start to accept not only USD, but other coins as a collateral, and we also plan to do that. So I think the biggest product market fit would be to use staked ETH as a collateral, because that would allow users and traders to earn yield their collateral and then trade on top of it. So yeah, I think that's kind of the two main trends we shall see next year.
Okay, looking forward to see what will happen. So so far we have no questions in the chat. I believe that your talk was very enlightening. So thank you very much. And I would say thanks to everyone for watching. Next up, we'll have an amazing workshop with Mike Voronov, so you can find the link to join it in our chats. And see you soon. Thank you for being with us. Thank you, Dmitry.
Thank you very much. Thank you. Take care. Bye.